Okay, previous part we discussed on the model for the voltage amplifier. So how the other amplifier model looks like. For example, current amplifier model. So current amplifier model is the input is current, so input is current, and then the output is also current. Okay, and then output is current. So if the input is current, so we consider the source of the current source. So the current source with the internal resistance will looks like this. And then so same goes with the inside the amplifier model. So instead of using the voltage source, we use the current source. So we have the AISC is current gain. So current gain, and then II is input current, and then the output of the model is the output current. So the output current will drive the load RL. So in this case, because this is a current amplifier model, so we can use the current divider. For example, if you want to analyze what is I, the input current, as a function of Is. So II is the current flow across the Ri. So the II is equal to Rs over Rs plus Ri times Is. So this is how you can use the current divider. Okay, and then the trans resistance. The trans resistance is the input for the trans resistance. So how to resistance is V over I. So the input is, this is input is current, and output is voltage. Okay, so the source should be the the current source. This is current source, and then since the output is voltage, we use the voltage source. Okay, please be noted that this symbol, the dependent voltage source symbol, is not accurate. So the accurate symbol should be in diamond. So okay, in diamond, so in diamond shape. Okay, so you have this one. This is voltage source. Okay, now you got the amplifier model. Okay, same with the transconductance. So transconductance, so if you see the conductance is inverse of resistance. So resistance V over I. So this is I over V. So the voltage will be the input, and then the current will be the output. So that's why the input is the voltage source, and then the internal source is the current source. Okay. Okay, this table summarizes the difference between voltage amplifier, current amplifier, transconductance, and transresistant amplifier. Okay, so we have the definition. What is the gain here? AV, AI, AG. AI is current gain, AG is transconductance gain, AR is transresistant gain. Okay, you may notice the word VOC. Let's say V out, and then OC. What is OC? So here OC actually stands for open circuit. So this is where there is no RL connected to output. Okay, so when there is no RL connected to the output, so the the output voltage is the maximum voltage generated by the internal source.